Hello students, welcome you all to our brilliant channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now and press the bell icon to get the notification of the upcoming videos. Students, I promise you to complete your syllabus and would like to solve all your queries which you may kindly drop in the comment box. As for my promise, I have completed your syllabus. I continue with higher Olympiad and IIT level from IIT Foundations. Today we continue with the chapter progressions, which is very interesting and an important chapter of class 10 level. What is progressions? You know very well what is arithmetic progressions. Then here in this class we will discuss about geometric progressions and what is harmonic progressions. Okay, then let us proceed with arithmetic progressions, AP. Arithmetic progressions is a sequence arithmetic progressions is a sequence arithmetic progression which is a sequence of representations of the numbers in a fixed rule. Suppose example 3, 5, 7, 9 are in AP. 4, 1, -2, -5 are in AP. This means representations of a sequence in a fixed rule where the suppose here in general form of an AP, Tn, the nth term is equal to A plus n minus 1 into D where Tn means Tn is equal to the nth term of the AP and A is the first term of the AP and D is the common difference. What is D? Is the common difference. Then here the sum of the first n terms of the AP is Sn. Here the Tn is the nth term of the AP where A is the first term and D is the common difference and Tn is the nth term of the AP. And in the sum of the nth term of the AP Sn, the sum of the nth term of an SC is represents by the formula n upon 2 whole 2a plus n minus 1 into D. Here A is the first number and D is the common difference or Sn is equal to n upon 2 A plus L where A is the first term and L is the last term. Here A is the first term and D is the common difference. And L means the last term. A is the first term, L means the last term and Sn is the sum of first n terms. Sn is the sum of first n terms. Okay. Then here the important points to remember is, here there is some important points to remember. Keep the formula here and let us discuss some important points to remember for arithmetic. Then you can easily, this is the tricks, important points to remember, tricks to remember for solving the problems easily, tricks to remember. First, if there are 3 terms of AP, then assume them. If there are the 3 terms on AP, assume that the terms are A minus D, A and A plus D. If there are asked assume any 3 terms of an AP, you must consider like this. Then it will be easier for you to solve the AP. Assume any 4 terms. If in an AP, if you have to assume any 4 terms, then assume like this: A minus 3D, A minus 2D. Here the common difference is 2D and A minus 3D, A minus D, A plus D and a plus 2d, a plus 3d. These are if you have to find out assume any 4 terms of an AP, then assume like this. Here if you have to assume any 3 terms, assume like this. Then if you have to solve the problems, just remember the tricks. It will be applicable in the next problems. I will tell you here there is the use of this. If they are asked the any form terms, then assume like this. Here the common difference is 2d. A minus 3d, a minus d, a plus d, a plus 3d. When you add them, plus 3d minus 3d cancel, d cancels, then you can get easily the value of a. If there you have to assume, if the third tricks is, if you have to assume any 5 terms of an AP, then assume like this: a minus 2d, a minus d. This is for 3 terms, this is for 4 terms, this is for 5 terms. Then a, then the third term is a, then the next term is a plus d, a plus 2d. Here the common difference is d. Then if you have to assume any 6 terms, of an AP, then assume like this: a minus 5d, a minus 3d, a, and a minus d, a, then a plus d, a plus 3d, and so look at here. If you have to assume any 6 terms, then here the common difference is also 2d. For even terms, if you have to assume even terms, 4 terms, then here you consider the common difference is 2d. Then the first terms a minus 5d, then the next term a minus 3d, then the next term a minus d, then the next term a plus d, then a plus 3d, then a plus 5d. If you have to assume any 6 terms, then here the another trick says that, fifth trick says that Tn means nth term is equal to Sn minus 1. Sum of n numbers minus sum of n minus 1 numbers. If you have to find out the nth term, then if the 3 terms A, B, C are in AP, if there are 3 terms A, B, C are in AP, then the arithmetic mean, then here the 2B is equal to A plus C. Here 2B is equal to A plus C. And the arithmetic mean AM is equal to A plus B upon 2. Arithmetic mean of any 2 numbers A, B are in AP is A plus B upon 2. Then the 7th trick says that if there are n in AM, arithmetic mean in between A and B, then D, if there are n AM, arithmetic mean there are n number of arithmetic mean between A and B, then here D is equal to the common difference, D is equal to B minus A upon n plus 1. The common difference is equal to between 2 numbers A and B is equal to B minus A upon n plus 1. Okay. Then let us discuss some important formulas. Let us discuss about some. In this class, I will say you the shortcut or the tricks of the progression. At first, we discussed about arithmetic progressions, next for geometric progression, then next harmonic progressions. Okay. Then here some important formulas. Sum of n natural numbers. Sum of n natural numbers. You know what is natural numbers? 1, 2, 3, 4, 5, 6 up to nth term. These are natural numbers. The sum of n natural numbers Sn is equal to 1 plus 2 plus 3 plus up to nth term is the summation of n is equal to n into n plus 1 upon 2. For example, if you have to find out the sum of the numbers 1, 2, 3, 4, 5, 6 up to 10, then here s of 10 terms is equal to 1 plus 2 plus 3 up to 10 is equal to, by applying this formula, is 10 into 10 plus 1 upon 2. This means 10 into 11 upon 2, which is equal to 55. Cancel 55. If you have to find out the sum up to 20, sum up to 20 numbers, this means s of 20 is equal to 1 plus 2 plus 3 up to plus 20 is equal to, s for the formula, 20 into 20 plus 1 upon 2. This is equal to 10 into 21, which is equal to 210. Okay. Then next important formula says that sum of the squares of n natural numbers. Sum of the squares of n natural numbers means 1 square plus 2 square plus 3 square up to n square. This is equal to sum of n square. The important formula of sum of n square is equal to n into n plus 1 into 2n plus 1 upon 6. This formula is easier to find out the sum of squares of n natural numbers. Then the third important formula says that sum of cubes of n natural numbers, 1 cube plus 2 cube plus 3 cube up to n cube is equal to sum of n cube is equal to n square into n plus 1 square upon 4, which is equal to summation of n whole square, which is equal to summation of n whole square. Okay. Then let us discuss about some properties of AP. Let us discuss some important properties of AP. In a fixed term is added or subtracted from an AP, then the resulting series is also an AP. The property says that if a fixed term is added, I will explain with example, is added. At first try to understand the property. The property says that if a fixed term is added or subtracted from an AP, subtracted from each term of an AP, from each term of an AP, then the resulting series is also an AP. Then suppose, look at here, suppose 1, 3, 5, 7, 9 are in AP. Here the common difference is 2. If the fixed term is added or subtracted, suppose we subtract 1 from each term, then this is 0, this is 2, this is 4, this is 6, this is 8. Yes, this is also an AP. If the fixed term is added, suppose 1 is added with each term, then the first term becomes 2, then next 4, next 6, 8, 10. Yes, these are also in AP. The first property says that if a fixed term is added or subtracted from each term, then this sequence is also an AP. Yes, we proved this. This sequence is also an AP. This is an important properties of AP. Then the second important properties of the AP says that if each term of an AP is multiplied or divided by fixed term, then the resulting is also an AP. Look at here. Suppose 1, 3, 5, 7, 9 are in AP. Then if the fixed term is multiplied or divided, if we multiplied each number with 2, then the first number becomes 6, then 10, then 6, then 10, then 14, then 18. Look at here. This is also an AP whose common difference is 4. Then if each terms divided by the same number, suppose here, look at here, suppose 3, 9, 15, 21 is an AP. Here these terms are an AP. Here the common difference is 6. Then if these terms is divided by a common number 3, then the first term become 1, then next 3, 5, 7. Yes, this is also in AP. This means the property says that if an AP is multiplied or divided by a fixed term, then thus the resulting series is also an AP. Here we get it. Here this is an AP. We multiplied each terms by 2. Then this series is also an AP. Here this is an example of an AP. Here if these terms are divided by each term divided by a fixed number 3, then the resultant series is also an AP. Okay. Then let us discuss geometric progressions. What is geometric progressions? You have already know what is arithmetic progressions, but in higher level, IIT foundation level, we will discuss about geometric progressions. Let us think about what is geometric progressions. GP. Geometric progressions GP is the series in which ratio of each term to the preceding term is constant. Ratio of this means the first term is A, next term is AR, next term is AR square, then is ARQ. In this way, this is a series of GP, geometric progressions, where the ratio of each term to the preceding term is a constant. AR upon AR square upon ARQ upon AR square is a constant, R. Here the R is the common ratio between two preceding terms. Example, suppose minus 9 by 2, 9 upon 4 minus 9 upon 8, 9 upon 16. These are in GP. Here the common ratio is minus 1 by 2. Here minus 9 by 2 into minus 1 by 2 is 9 by 4. The second term. Here the 9 by 4 into minus 1 upon 2 is equal to minus 9 upon 8. The third term means here the common ratio R is equal to minus 1 upon 2. The GP, geometric progressions, is represented in this form: AR square, ARQ. The first term, the second term, the third term, fourth term. The R is the common ratio. And another example. Here another example says 0.01, 0.001, 0.0001. This is also NGP, where the common ratio R is 1 upon 10. Here this is in GP and the common ratio is R is 1 upon 10. Here each number is multiplied with 1 upon 10. The general term of GP, Let us keep it here and discussed. Let us keep it here and discuss. The general term of GP Tn, the general term of GP is equal to A into Rn minus 1. Here in case of arithmetic progression, the general term Tn in case of arithmetic progressions, Tn is A plus n minus 1 into D. In case of AP, in case of GP, the nth term Tn is A into Tn is A into R in Rn minus 1, R to the power n minus 1, where Tn is the nth term of the GP. Nth term of the GP. Please students, note down the important points and be attentive. And if any doubt, please ask me in my comment box. I am ever ready to clear all your doubts. Where A is the first term and R is the common ratio. R is the common ratio. As I have already told you, the GP is the representations A, AR, AR square, ARQ, where A is the first term and R is the common ratio. Then here assume the three terms. If you have to, let us discuss some important points to remember for GP. There we discussed about important terms of points for AP. Here important points to remember for GP. Important points to remember for GP. If there are three terms in GP, then assume them as A minus A upon R, AR. Then if you have to assume any four terms, then assume like this: A upon RQ, A upon R, then AR, ARQ. If you have to assume any five terms, here three terms, here four terms, if any five terms, then assume like this: A upon R square, A upon R, AR, AR square. Then if you have to assume any six terms, assume like this. If you have to assume any six terms, then assume like this: A upon R to the power 5, then A upon RQ, then A upon R, then next AR, ARQ, AR to the power 5. Then the fourth point says that if three terms A, B, C are in AP, if A, B, C are in GP, then B square is equal to AC. In case of AP, when three terms A, B, C are in AP, then you say that B is equal to A plus C upon 2. In case of AP, but this is case of GP. In case of GP, B square is equal to AC. Then the geometric mean between A and B. Geometric mean between A and B is square root of AB, where the arithmetic mean between A and B is A plus B upon 2. Arithmetic mean, where the geometric mean is square root of AB. If there are n is the geometric mean between A and B. If there are n the geometric mean between A and B, then here R is equal to B upon A to the power 1 upon n plus 1. Then students, today this much. In my next sessions we will continue with these progressions. Thank you students. Happy learning.